this unit, we're going to study similar figures. In this lesson, we're going to be looking at applications that use scale factors. Okay, hi everybody. So in this lesson, we're going to look at scale factor applications. So basically, we're going to look at some word problems associated with the work that we've been doing on scale factors. Okay, and then reducing something or enlarging something. Okay, so here we go. Just read this out for you here. So people use scale factors. The number we multiply each side length on one polygon to get the corresponding side length on a similar polygon in their work or hobbies. Okay, so people often want to create a representation of something that already exists. They want to make it scale it up or they want to scale it down. And remember that typically what we're going to do here is we're going to have like the new side 1 compared to old side 1. That ratio, that should be the same as the length of the new side 2 over the old side 2. Okay, and that's kind of how we're going to build this. And remember, this ratio here is going to equal our scale factor. So anyway, let's take a look at some examples of how that'll work. Okay, so let's go through and do some questions. So Josh has built 2 stools. The second is slightly larger, but similar in shape to the first. If the first stool has a height of 18 inches and a diameter of 20 inches, and the second stool has a height of 22.5 inches, so here we go. So here the height is 18 inches, and then the diameter here is 20 inches, and then we're going to make this bigger one here. It's going to have a height of 22.5 inches and a diameter of 25 inches. What scale factor did Josh use here? Well, remember, for our scale factor here, that's going to be the new to the old, and we can determine which of these dimensions we're going to use here. But we've got everything we need. In fact, we've got even more than we need. We know that these two are similar. Okay, so what we're going to do is we're just going to pick one. Let's pick the diameter here. The new diameter is 25. The old diameter is 20 inches here. 25 over 20. Okay, we pull out the calculator just to get the decimal version here. 25 divided by 20. And we get that our scale factor is 1.25. Now, just to be clear, the reason why I did it like that, I'm treating the second one here, the larger one, as the new one, is because of when it said here, what scale factor to use to make the second larger table. So this was the new one. Okay, just to be consistent with the wording there. Here's another one. A department store uses gift boxes to wrap items they've sold. They have different sizes for different items, but all boxes are similar in shape here. So if one box is 20 inches by 12 by 5, and a scale factor of 1.3 is used. Now, notice that the scale factor is 1.3. That's larger than 1, which means when I multiply each of these by that scale factor, 1.3, I'm going to get a larger number. The reason I say it like that is because that means that the 20 by 12 by 5 inches is this smaller box. 20 inches by, let's say, 12 inches by 5 inches. Okay, so this is our old, and then here's going to be our new one here, and we're going to use a scale factor of 1.3. Now, that means that for me to get my new length here, what I got to do is take the old one, whoops, I want to make sure you can see that, and I'm just going to multiply by 1.3. That's how we scale it up. Okay, so 26 inches. Okay, so that was going to be 20 multiplied by 1.3 got us 26 inches. So our length here was going to be 12 times 1.3. 12 times 1.3, 15.6 inches. And then finally we're going to do the 5 multiplied by 1.3. And we get 6.5 inches. So here are the dimensions of our new box here, 26 inches by 15.6 inches by 6.5 inches. Okay? So even the term scale factor sort of tells you what to do with it, because the word factor implies that we're using that number as in multiplication. We're going to multiply by it. So now draw and label the dimensions of a rectangle that has a length of 12 centimeters that is similar to a rectangle with a width of 15 centimeters and a length of 30 centimeters. Okay, so we've got our rectangle here, and this is going to be 12 centimeters. There's our length. Now, I don't know what it is, what the dimensions are here, but I know that it's going to be similar to this larger rectangle, and it's supposed to be larger, that's got a length of 30 centimeters and a width of 15 centimeters. Now, I apologize that my 30 centimeters and my 12 centimeters here are going to look very similar. I should have drawn that longer. But you get the idea. The thing that I'm missing here is the width of the smaller one. So let's call this one, well, okay, let's call this one the old one and call this one the new one. It doesn't really matter as long as we're consistent. So my scale factor here, my new length to my old length, should be the same as my new width to my old width. In this case, that's going to be x. So I have enough information to set up that proportion because I do have the lengths of two corresponding sides, the two lengths. Now I cross multiply. Okay, and then 15 times 12 is 180, so 30x is going to equal 180. Then I'm going to divide both sides by 30. Okay, and I get 180 divided by 30, and I get 6. So what that means is my original rectangle here has a width of 6 centimeters. Now, our last question here. Sally made a kite with the dimensions shown below. So it's got basically it's 20 centimeters from the outside to that middle pole there. That little bit there is 8 centimeters. This is 40. It says here our tail is 28. She decided it would work better if it was bigger. So now, all we know here is that the new kite tail is going to have a length of 49 centimeters. So what scale factor did she use? Now, bear in mind, this is the new, this is the old. So our scale factor here is going to be new, 49 centimeters over 28 centimeters. So what does that get us? 49 divided by 28. Okay, and I get 1.75. So there's my scale factor, 1.75. Okay. That's what I'm going to use to find all the other dimensions here. So the next question here is determine the dimensions of the enlarged kite. Okay. Well, my scale factor, and I'll write this up here, is 1.75. That means here, for this 20, I'm going to multiply that 20 by 1.75. So this becomes 35 centimeters. This little depth here at 8 centimeters, I'm going to multiply that 8 by 1.75. And I get 14 centimeters. So right here, 14 centimeters. This right here is 40 centimeters, the total height there, times 1.75, and we get 70 centimeters. And this would have worked equally as easily had this been a reduction, had we gone from here to here. Our scale factor would simply have been a number that would have been a fraction less than 1. And then, but you're just going to multiply to get the dimensions of the new shape, regardless of whether you're enlarging it or reducing it. Okay, so I hope that helps clarify how you do this sort of math.